Okay, let's start our test review for Friday's test, Systems of Equations test review. I kind of already started without you guys. Number one, when you have two parallel lines, how many solutions do you have for the system? No solutions. Parallel lines never touch, so no solutions. The next one, how many solutions do I have on this intersecting pair of lines? One intersection. An intersection is a solution. Where does that occur? This graph is terrible, but let's just call it 0, -4. For the third example, the third graph here, we have only one visible line. That means we've got a case of overlapping lines. In other words, we graphed the same line twice. How many times do overlapping lines touch? They touch from here to infinity. You have infinity solutions, infinitely many solutions. Okay, so that is your 3 types of solutions for intersecting lines, for systems of linear equations. No solutions, parallel. One solution, give me the point where they touch. Infinity solutions, because the lines are sitting on top of each other. They are intersecting at every single point. Number 2, what's the value of x in the solution to the following system? If you don't read directions first, you're going to do way too much on this problem. I don't need you to do the second half of the problem. Only do one half. Solve for x and call it a day. So let's set up this system so that we can eliminate the y's, get them out of the way since we don't even want to know what y equals. It's unnecessary. How can we do that? We've got opposite signs on the y's already. So what's the missing digit down here? I want opposite values. So the opposite of +5 is what? -5. I would love for this to say -5y. What's the missing digit? 5. All I have to do is multiply this bottom equation by 5, and I can get that done. The top equation stays exactly the same, and the bottom equation gets pumped up equally. Every term gets pumped up by a factor of 5. Pump air in every tire so your car does not wobble. 5 times 2x, 5 times -y, and 5 times -20. Then we get ready to add our equations together. We've got opposite coefficients on y, so that's who we've targeted for elimination. 10x's plus another x, -10 plus -100. Don't be shy. Use your calculator. You might know what it is, you might not. I've already done it, okay? So that's -110. Then you're gonna divide by 11, and what do you get? X equals -10. And we're done because the question asked us for the value of x. Why would I do more? That's all they want. Problem number 3. Use elimination to find the solution to the system of equations. And I gave you a hint. Read that, okay? On the test, there's no hints, but on your test review, there are. You're going to rearrange one of the equations. Well, I know that standard form is required for me to use elimination. And standard form looks like this. X comes first, then y, then my equal sign, and then my constant. That is not the case with this top equation. The bottom one's good. Top equation is not okay. So let's rearrange those terms. We're going to switch the 6y for the -4x. Okay, remember, when we rearrange these, the sign travels with it. But miss, don't I have to change the sign? No, we're not jumping across an equal sign. All I'm doing is rearranging terms. The sign travels with it. So this is what it's going to look like. -4x, +6y equals +18. Bottom equation stays the same. There's nothing wrong with it. And now we can proceed to think about elimination. So we need both solutions, so it doesn't really matter who you wish to target. Let's just target the x's, okay? Can I turn a 4 into a 3? No. Can I turn a 3 into a 4? No. And just for that matter, can I turn a 6 into a 5 or a 5 into a 6 by multiplying by a whole number? Absolutely not. So we're targeting the x's just because. At this point, neither one works out the way we wanted to. Let's just target x. If I multiply the 3 by this coefficient, and if I multiply the 4 by this coefficient, if I multiply them by each other's coefficients, then I will get a common multiple. It might not be the least common multiple, but it's going to be a common multiple. So let's do that. The signs are already opposites, so we're okay with the signs. We don't need to think about the signs. Just multiply by the absolute value of the number, by the digit. Okay, so I'm going to take 4 and times it by 3, or the top equation anyway, times it by 3. And I'm going to take the bottom equation and multiply it by 4. And you're going to see right now what that does for me. Okay, so I will have 3 times negative 4, negative 12x. 3 times 6, 18y. 3 times 18. Now for the bottom equation. 4 times 3x, 4 times negative 5, and 4 times negative 8. There we go. Now we add as usual because we have opposite signs on the coefficients, okay? So negative 12 and positive 12, what happens there? That's the whole point. If nothing cancels, if you don't get 0 for anything, and I mean get 0, don't just cross stuff out because it becomes a habit to. Check it. You should get 0 before you cross something out, okay? So negative 12 plus 12 is 0. 18 plus negative 20, 54 plus negative 32, and then we divide by the coefficient of y, and we get y equals what? Negative 11. We are halfway there. We do need the full answer on this problem, so let's keep going. Let's plug this into one of our original equations. I'm going to use that one because that one was crazy. So let's do 3x minus 5y equals negative 8. Let's plug in our y value. So I just plugged in my y value, like that, okay? So let's clean that up. What is negative 5 times negative 11? That's positive 55. Okay. And you can finish that on your own. How do we check solutions? How do we check solutions? Don't forget that at the very end you can check solutions. I'm going to let you finish that problem on your own. So pause it and then you can finish that and then move on to problem 4. Look at number 4. When using the elimination method to solve, practice performing the first step in the process, meaning the setup portion. You can set up the equation so that the x's are opposite, then do not solve. And then you can set up the equation so that the y's are opposite. We want to practice 2 setups here, okay? Because a question on the test might be, which is an appropriate first step to solving this system? And then you've got to recognize it when you see it. So let's try it. Let's set it up here. I'm going to do 2 halves. Let's set it up so that the x's are opposites. Eliminate x's. And then this will be my eliminate y's setup, okay? So, to eliminate the x's, I need to get opposite coefficients here on my x. So what can I multiply 3 by to turn it into a 12? I can multiply it by 4. And then I also want to make sure my signs are opposite. Pre-AP, you know, same sign, subtract. You don't have to worry about the signs. But here we are. Let's make sure our signs are opposite as well. So everybody gets multiplied by a negative 4. So my first equation is not going to change if I'm eliminating x's. It stays the same. But my second equation, everyone gets pumped up by multiplying by negative 4. So we'll get negative 12x, negative 40y, and negative 60. So that could be a possible first step if I'm targeting the x's. Now, if I'm targeting the y's, what could be my possible first step? Okay, let me copy this system down again so you guys can see. Okay, so this is just this problem copied one more time. If I want to eliminate the y's, how can I make a 2 into a 10 by multiplication? What do I need to times this by to get a 10 here? Well, by 5. And are my signs already opposite? Yes, they are. So don't mess with the signs. Keep this a regular positive 5. Do not mess with the signs. To change signs, we would make that into a negative, but we don't want to change signs. We're happy with the signs. So let's go ahead and see what our setup's going to look like. 5 times 12. 5 times negative 2. And 5 times 20. And then my bottom equation would stay exactly the same. And now my setup's ready. I have opposite coefficients on y. Okay? Opposite coefficients on y. I'm sorry, you couldn't really see that. Okay. There we go. For the second half of the test review is mostly graphing review. So let's look over here at our second half. For number 5, both equations are already solved for y. Both equations are already solved for y, so all we have to do is type them in our calculator. Go to y equals. Go outside. Okay. Hit graph. Make sure the 2 lines cross. Second, trace 5. Enter, enter, enter. And we get 1/6. Okay? For the second equation, you have to, this one's already ready for the calculator. That's solved for y already. Second equation, solve for y. Grab it, jump it, change the sign. And we have what? Y equals 10 minus 4x. Now it's ready for the calculator as well. You could do that exact same thing. Remember, you can use your online graphing calculator at desmos.com to help you get this graphing done. Next, determine if 5, negative 4 is a solution to the system. When we're checking solutions, we plug in our x value, we plug in our y value, and we make sure it makes a true statement. I can do this on my calculator or I can do it on paper. Either way is fine. So we're going to plug in, this says x plus y, so 5 plus negative 4. Does that give me 1 like it's supposed to? Let's see. Yes, it does. So 5 plus negative 4 equals 1. Check. For the bottom one, 5 plus, 5 minus negative 4. Does that give me 9 like it's supposed to? Yes, it does. Check. Okay? For question number 8, there are 2 ways to do it. You can check each one of these solutions by plugging it in like I just did. Or you can check 7, negative 9. Plug that in for x, plug that in for y. Also here, plug that in. That's a negative 7 and a negative 9 this time. Plug that in for x, plug that in for y. Okay, do that just like you did problem 7. For problem 9, both of these are calculator ready already. But when you go to plug in this bottom one into the calculator, the top one's easy, negative 2x plus 5, calculator ready. But for the bottom one, you cannot just type it in as you see it, plus 10 and a divided by 2, because this calculator does order of operations. 10 divided by 2 is all it's going to do, and then it's going to add 5x. If I wanted to divide the whole thing by 2, how do I tell the calculator to divide the whole top by 2? I have to put parentheses. Now it's calculator ready. Whoops. Now it's calculator ready. Oh boy, I messed up. Now it's calculator ready, and you can graph it and do your second trace intersect thing. Okay, that's it. Good luck.